So welcome, hello. I'm going to talk a bit about real APIs in Rust. So as Hugo already told you, wait, is it working? Yeah, let's see. Yes, it's working, thanks. Okay, so as Hugo already said, I also work at Tweede and I'm a senior developer here. And at Tweede we make mainly REST microservices and also single page applications using mostly React. And also we have a bunch of monolithic applications that were written in the past, but we're still actively developing for our customers. So during this talk, I will mainly focus on microservices, specifically microservices written in Rust. So microservice, it's a buzzword, but it also means something interesting. So when you have an application, you can either build one big piece of software and that's your whole application, but you can also make a bunch of small applications, microservices, and those form your real bigger application. This has some benefits. You've got smaller concerns for each microservice. You have a specific set of concerns. It's simpler to outsource your microservice, for example, to Tweede. So a lot of our customers also have like a specific microservice they want us to develop, and then we can make it for them. It's also simpler to test whether your application functions correctly, your microservice. But it's harder to test the whole of the application. If you have a bunch of microservices and something goes wrong with one of them, it's harder to diagnose. At talks of microservices, they specifically mention that you often have cascades of failures. Like one thing fails and then all your other microservices fail in a cascade. So that's hard to test. So at Tweede we mainly use PHP for standard backends. And over the last year, 2 years, we've moved towards Node.js for these kinds of solutions. And our more demanding services are written in C++. But more recently, if we have the need for like high confidence in the correct functioning of the microservice, and also have a need for performance, we think, of course, about Rust. So one of the applications that we've written in Rust is the backend for this thing. It's called micromaps, and it generates small map tiles. So when you have like Google Maps and you zoom in and out, you see like little squares of pictures come up. Basically, this Rust microservice generates these kinds of smaller images. The actual rasterization, rendering of the images is done with an open source library called MobServer, which is a C++ library. But all the business logic is written in Rust. And we also made like a library that provides a safe Rust shell over this C++ library. And the web framework used is Hyper. So the lower end, or lower level web Rust server available. So the mascot of Rust is a crab, and the mascot of the web is a spider. So this is a crab spider. But of course, we don't want a crab spider. We want a spider crab. So how does this spider crab look like? So the web working group, or the net web working group of Rust, has a website called Are We Web Yet? And it tracks the status of the Rust ecosystem for web development. So they've identified several topics, and they've looked at like all the crates available and categorized them, and they have some vague sense whether the ecosystem is ready, is web yet. So for each of these, it indicates like it's unstable or everything is awesome. Well, actually, nothing is awesome according to this diagram because nothing has this icon. But hopefully we'll get there one day. So as we know, Rust is very good at the heavy lifting. It's capable of doing hard computations really well. Because it's a lot like C++ in the respect that it's a systems language. But actually, at Tweede we're not very interested in the hard stuff. Sounds bad, right? But I'll explain. We're mostly we're interested in the boring stuff. Most of our work goes into making simple type applications. And of course, we'd like to spend less time doing simple things. So one of the simple things that we spend a lot of time on is implementing CRUD-like operations. So if you have a database, you have your records in your database, so your rows in your tables, you want to be able to create, read, update, and delete those records from your database. So we spend a lot of time simply defining our entities, defining our schemas, and writing boilerplate code so that we can do this stuff. But can we make it simple in Rust? So what we did is we made a little framework that implements these CRUD operations really easily. But before we could do that, we had to specify a few areas within the RE web-get that needed to be really good. So for the most typical thing that we make at Tweede, we actually only need these 4 things to be really good. So we need authorization authentication, we need database support, we need serializers, and we need to be able to talk to other microservices, external services. So yeah, we made a little web framework for CRUD operations. It's really small. I'll show you what it looks like. So we already have done some heavy lifting using Hyper, but we wanted a framework that's easy to work with. So out of all the web frameworks that were available, we chose Rocket because it states that it's really simple to use and it's really powerful routing-wise. So we thought, let's give it a go. We mostly work with Postgres databases. So we chose Diesel to talk to the database. And we need some kind of authentication thing. So nowadays in the web, OAuth is the way to go. And you want to store your sessions using JSON Web Tokens. So that's what we did. So this is more like a research project. And we wanted to see whether it was good enough to use for like most of our other programmers. So therefore we defined these goals. It needs to be really easy to define your data model. It needs to be really easy to use. It needs to provide all the functionality you need, and it also needs to have comparable performance to our previous solutions. Because if we make this and it's worse than PHP, then what are we even doing? So a framework is nothing without an actual use case. So one of the use cases we have is this. So throughout our office, you can see screens. I think they're now turned on because it's after working hours. But this is our status panel. So we have Raspberry Pis hanging everywhere behind screens, and they show us the status of our organization. But basically what you see is Git commit messages, like what's the weather like, which kenteken, number plate is currently assigned to our permit, parking permit, how many emails we have in our support mailbox, and also which servers are down. So this one does not respond to pings anymore, for example. Probably because someone just added it. And it also shows a warning light when it happens, when something goes bad. So yes, this is written in JavaScript, the front end. It's interesting, but not interesting for this crowd, I think. What's interesting is how it gets its messages. So we have various sources, like something that pings servers, apparently. And those messages need to be filtered out, like the stuff we don't need needs to be filtered out, and also they need to be transformed into something that this status panel understands. For that we use Logstash, which is a project affiliated to Elasticsearch. And basically all it does is it takes messages and transforms them or filters them and passes them along to something else. for example, an Elasticsearch database, or in our case, our status panel. Problem with this piece of software, it's written in Java. It's not a problem in itself, but the scripts are written in Ruby, and it takes about 2 minutes to start the systemctl unit, at least with our configuration, because there are like 50 different scripts, and it takes over 1 GB of RAM. So that's a bit odd for something that only filters messages. You expect something like that to cost like 1 MB of RAM and boot instantaneously. So that's what we've written in Rust, something that will replace this. Because it's a research project, we also need to assign some different functionalities that we normally not assign to this kind of application, but just to be complete, to be able to determine whether it's usable for all our use cases. So we also made a small front end in, again, JavaScript, just to show us, oh, hey, we also need filtering, and we also need sorting, and we also need pagination. Otherwise, we wouldn't have come up with these requirements. So we also want those to be really easy to implement. So let's jump right in. So we use Diesel to connect with our database. I'll now show how we try to use Diesel in this framework. So Diesel is a database abstraction layer, which means that it provides an abstraction over various kinds of databases, which might have like a different dialect of SQL, for example. So here we have Postgres, MySQL, and SQLite, and you all talk to these databases using the same interface. You have the Postgres crate that already exists, but we don't use it because it's not very rusty in the sense that you still need to type like string queries, and you assign like values to members of your struct, but they're not really statically typed, they're only checked at runtime. And we of course want like a completion error if we assign the wrong type of value from the database to a struct. So Diesel provides this by first forcing you to define a schema, which is like the type in Postgres. So it looks like this. So we have a table macro, which comes from Diesel. You define the table message of the table name, messages. You define a column, ID. It has a type, serial, which is a Postgres type. And then you just put it in your Rust code. Well, we use databases and not like plain text files because we want to have relations and stuff like indexes on relations. So if you have a relation table, you have an events table, for example, which is different from messages. You have source ID, which apparently is some reference to another table, and you specify not the table it reference to, but the type of the reference, so in this case, an integer. And then, oh, I see I need to fix this, just a moment. So here's that joinable, and basically it points the events table to the messages table using the field source ID. So now Diesel understands that this relation exists, and it will probably provide some functionality around that. So for the Diesel model, so we just defined the schema, which is like the Postgres type, but we also need to give it a Rust type. So now it's a bit smaller, but it's still reading, right? This is fine, right, for everyone? Okay, yeah, so this is better. So we define a struct message, which is the Rust struct. We'll need to define a bunch of Diesel stuff to get the functionality we need, and we need to refer to the messages table, which is the schema table. We have, again, the column we just had, ID, but this time we specify a special type, which we defined ourselves, which is ID that knows for which kind of object it is. So basically it's an integer, but it also has the marking of the originating type with phantom data. This way you cannot accidentally use the ID for an event in place of the ID of a message. The compiler checks it now for you. But also, if you want to make a new message, we have to define a separate struct that does not have the ID field. because it does not yet exist in the database. It doesn't have an identifier yet. So this is a whole bunch of code, and I don't want to write this, right? This is how you use Diesel classically. So in this case, we just specified our old style macro. This is not a proc macro, but an old style macro that generates this. So this converts to this. So now this is easier for our programmers to write. Okay, so we also need to have operations on, like specific CRUD operations on our types. So I'll now show how Diesel wants you to do it. So if you have an idea and you get maybe some struct, you can already see this is from a macro. You want from a schema filter the fields that have the same ID as you are searching for. And you will want to yield the first row from that result set. Probably it's only one result. But also, we want to specify to what kind of Rust struct it gets converted. So for example, I could make a struct with a bit less fields in there to minimize the amount of stuff that gets transferred around. So if I'm interested in one field, I just specify a struct with that one field. Then also I will finally yield either an object, or if I get a not found error, I'll yield no result. So again, this is a lot of code, and I also need to define this for update, delete, and create. But we have a macro for that, which I could arguably put it in there, but it's now a separate thing, but it all does that automatically. And then we get an implementation for this trait for that type. So we get create, find, read, update, and delete. Yay. So how do you use this? So if I have, if I want to make a new message, I first have to make like a pure Rust new message. Then I can promote it to an actual record in the database, which is not of the type new message, but of the type message. It has an ID in there. I can find again that same entity by looking up it using the ID. And I can update a field by updating a field. It will unfortunately update the entire struct. So it will upload the entire thing and just overwrite the record again. But for CRUD, that is fine, actually. OK, so now I have CRUD. And I've used Diesel for a bit. And I can conclude from that that object relational model in combination with Rust is really nice, because you have like type checking and stuff. We don't use the database abstraction layer, because we only use Postgres. That's fine, I guess. It's a necessary abstraction for us. The downside really, though, is that it's not Rust 2018 yet. And because Diesel is very macro heavy, it can conflict a bit with how Rust 2018 operates. Especially if you want to re-export some Diesel stuff because you made a library, like a framework that provides CRUD operations. It's really hard to get those macros right. Also, Diesel is not async, and it will probably not be in the near future. Well, this is from 2017. Oh. And to be fair, he has said that he would probably implement it as an experiment now that Future 0.3 has landed. But he doesn't have the time. So if any of you have the time, feel free. So let's talk about Rocket. So Rocket is a web framework. So basically what it does for us is it does all the HTTP stuff, and it allows us to do interesting logic and yield HTTP responses. So how do we do that? We first have a handler, message find, which implements one of our CRUD operations, and we bind it to a route /message. This handler has some path, in this case like a generic path, and it accepts an ID parameter, and in this case it gets an integer. So in this case, Rocket for us can check that it's actually an ID, and if it's a string or something that does not look like an ID, it will throw an error. Rocket is really nice in the sense that you can like make a database pool, say to it, manage this database pool for you, and then you can pull a connection from it in your handler, like magic. I will show how this works in a moment. And then you can actually call that CRUD operation that I just defined to get your object, or not. So we can also do the same thing with like authorizations. So we have an authorization handler that is able to check permissions and give you access, or not. So how does that or not work? Like we implemented some errors, really rusty, in the sense that you have an enum with various options, and like you have the forbidden error, authorization is not available for user, or database error. But yeah, you can't do anything with these concretely, but you can cast them to like actual HTTP error codes, like 403, and yield that as a Rocket response. So with this trait, Rocket understands errors, which is nice. We can do the same thing for connections. We can say, hey, I know how to get a connection for a request using a database pool. So here you say, give me a connection pool, and then it will give you a connection, or not. Let's talk about Tide. Who knows what Tide is? Whoa, okay, that was not expected. So Tide is a new web framework in Rust, but it's more like a conversation about the standards and the process of creating a generic interface to provide web services, and less about actual implementation. It's started by the web working group, WebNet async working group combination. Yeah, so they are talking about standards and trying some stuff out. Now there's code, but there wasn't code in November. So we didn't actually use this framework. But I will show you how you implement the same thing instead of using Rocket with Tide. At least what's on their repo as of like this week. I hear they're already considering changing the interface again. So this is no longer relevant in 2 weeks. It's like a general overview. So again, the same way you have a database. In this case, it's an in-memory database, just to illustrate it. But you can give it to the app. That will be their entire context. So if you need to have other stuff, you need to make a different struct with your database in there. You have routes and you have handlers in the same way, but this one is async. We need this. You get your app data, which is like your context, your database. You get your ID from the path, and you can look it up and yield it as a JSON. So it's very similar to what we saw in Rocket. There are some points where it's different, but in this case, it's quite similar. And it's async, which is nice. So basically, our framework is already almost done now, but we still need to have those nice features that were from our user interface, which is filtering, sorting, and pagination. So this is an URL, and there's a filter in here, and there's another time span filter in here. So we want stuff like this to be understood by CRUD macros. There's one problem. This is written in Rocket 0.3, and it has a nice, not so nice problem in the sense that you always need to put a question mark after every path if you use this parameter pack features. In Rocket 0.4, this has been fixed, but as you can imagine, also the API changed. So it will take us probably like a day to fix this. But let's focus for now on the pagination, and you can implement it using a limit and an offset. So I want 100 records, starting from record number.
Hello. Question.
Yeah.
Maybe you can answer it later, but I'm really interested in why this changing with the query parameters, why this has so much impact that you need to work a day on it. I'm really curious. So
Yeah.
how does instability of Rust affect you in your productivity? But maybe you can get back to that later.
I will first show how our implementation looks, and then I will answer it afterwards. Right? Okay. So so we have our limit and an offset, and we need to get that from our request parameter bag. So first we need to implement like a struct which will hold our limit and our offset, and we have a macro here that builds the fetching from the Rocket parameter bag to this struct. It does so. This is a really big macro. I didn't want to bore you with it. But then also, we need some other options like filtering on time frame or filtering on specific message fields, which will form all the possible parameters accepted by the messages endpoints. So we've done this using the query parameter group trait that Rocket sort of provides in the old interface. In the new interface, all these things no longer exist. And they have like a radical new, better interface to specify it. So yeah, right. So then we have this struct filled with our limit and our offset. And now we need to implement for our message struct the method read, in this case, because we want to read given these sets of filters. So we have these parameters, and we have our database connection, and it will yield a list of messages. It could also be an iterator, but in this case, we went quick and dirty. So from our messages schema, which Diesel provides, we need to get a query builder. There's one interesting thing about Diesel, and that's it does not only provide like methods to perform a query, but it also provides like a little domain-specific language to write your queries in. And this domain-specific language is typed. So you cannot possibly write a wrong query using this query builder. The downside is that it's typed, which means that at compile time, it will have a different type depending on what you call on it. And as it happens, the number of parameters that are actually filled in this endpoint varies depending on what the user wants. So our query will change depending on what the user wants. Thus, the type will also change on what the user wants. Thus, you need to box it so that the type is up there and not really at compile time knowable. So we've defined a macro to apply a pagination. I'll show it in a moment. And given a query builder, it will yield a new query builder. I'll also explain why it's a macro in a moment. And then finally, given this query builder, we will generate a query from it and load it. And we will yield the messages from it. So on towards the macro. So we have these limit and offset, and they may or not be set. So if they are set, we set the limits to some maximum or minimum, or we set it to some default or nothing. We don't do anything with it. And we will pass this query builder along again. So this is a boxed query builder, but still these methods do not understand the fact that they're boxed. They work on a boxed object, but they will yield back a type that is not boxed, or at least that it just implements some trait. So you then would need to box it again or something, but that's not possible within the typing framework of Diesel. This means that I'm still stuck with something that's that is boxed and practiced, but once I call one of these functions, it's no longer visible as a box type within Rust. So then again, I have the problem that I cannot write down the type. It's not like I can say it's from some kind of trait like this. It really depends in this case. So that's why, because I cannot write down the resulting type of this function, that I need to use a macro, because then I don't have to write a result type. Sorry?
If you write down function.
To writing the return type of that function. Yeah.
Can't you write an input type?
Yeah, but you can't write down the resulting type, the trait, resulting trait. So maybe because some aspects might be private or something, but I don't see really how. But if you want to look at it and try to write down the type, I would love to see it. But that's because, like, I wrote this in company time, right? So at some point you just have to say, okay, I cannot conceivably write down this type. I'll just make a macro out of it. So yeah, if you like a challenge. So yay, our framework is done now. Which is really nice. Okay, so and also our proof of concept, like the application is also done now. So it's actually running right now. So let's inspect one more interesting aspect of this story, and that's performance. So you have Tech Empower, which is a company that also apparently has a very nice web framework benchmark for all kinds of web frameworks, JavaScript, C++, Java, whatever. Of course, dependent on the quality of the people implementing actually these separate benchmarks implementations, but it's very nice to look at. So I was wondering, how well does Rocket perform? Because, well, I know Hyper performs really well, and Rocket is a bit simpler, but also prides itself to be really fast. So plain text responses, so no actual work, just yielding a plain text blob back. Where is Rocket? Oh, that's not good. What? So apparently, Rocket does not do so well. Also, apparently it drops connections once it gets saturated, which will result in errors during this benchmark. It does not just block a connection, it just drops it. So apparently I chose wrong in using Rocket. Hyper is really cool. Also like Actix Web. So Actix seems nice. Tide isn't in here yet, probably because it's hard to implement these benchmarks. You could do it using Tide. So maybe I would do that in a few weeks or something. So, but of course, we expect Postgres to be a lot slower than one of those web frameworks. So using just a few read queries, how well does it perform? And again, you see like Rocket has a few problems, but more interestingly, Actix has both the Postgres and the Diesel implementations. So this is just a Postgres crate that I showed earlier. And apparently, Diesel is like 4 times slower than Postgres. Note, this is an async implementation. So it uses actually Tokyo Postgres async to do this. So either it's because Diesel does something not very efficient in some places, because I still would expect the I/O of Postgres to dominate the bottleneck, right? But yeah, apparently it's 4 times as slow. So maybe async will really help if we do make it for Diesel. Yeah, this is really disappointing, right? So we had this promise. I inspected like the normal frameworks that we use for PHP and Node.js, and actually our Rocket implementation is about in the same ballpark. A bit faster maybe, but not a lot faster. So a bit disappointing. So how well did we do with our research project, right? It's easy to define. Like the model was really short to define. It's somewhat easy to use. I mostly denote this to the fact that we still have to provide all those parameter packs and like combine them in a tuple and then do lots of mechanical things. Maybe I could make like an easy derive macro for that, but that's still to do. It provides all the functionality we need, and apparently the performance is not that good. So barely there needs some serious work. I have not yet talked about authentication sessions. We would like an open API specification to be generated automatically from Rust types, and also testing. See also, so the talk is on here. Rocket, Tide, very interesting. Are we web yet? And the benchmarks, if you're interested. Thanks. Are there questions?
Yeah, how did you end up with Rocket then, if you're considering the last two issues?
Yeah, so I looked a bit at benchmarks before I started using Rocket, but apparently these benchmarks were like updated for Rocket like really recently, only 2 months ago. So I only noticed the performance loss after I had implemented a bunch of stuff. The main driving reason for choosing Rocket was it's simpler to use than Hyper. That's certainly true. And also it's quite powerful in some regards. So the routing is pretty powerful, like with those parameter pucks. Most other frameworks did not have that at like November time. And also it has a bunch of, like it understands what cookies are. It understands multi-part forms really well. It has session support. So it has a lot of baggage, which is nice to use for like if you just want to make something quickly, which is the use case for this kind of CRUD API. If you want something like really high performance, we still would have chosen to use something like Hyper. Yeah, but for this, easier to use, simpler is better. Yeah.
More questions?
Yeah. Thanks.